La 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 la. La 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 la. La 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 la. La 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 la.
Here in this video, we are solving a problem in potentiometer. Let's read out the problem first. Problem is like this. A potentiometer, a wire of length 10 meter and 20 ohms resistance is connected in series with a resistance R and a battery of EMF 2 volts with a negligible internal resistance. Let us try to visualize this part of the problem before going ahead by drawing a diagram. It's like this. If you remember back the potentiometer, it has a wire AB. It is given that the length of that wire is 10 meters. Resistance of that wire is 20 ohms. Then it will be having some primary circuit with a cell. This cell is having some EMF E, having some internal resistance R, but it is given that it has a negligible internal resistance. So I write this R equal to 0. This is further connected to a rheostat, if you remember how potentiometer works. And that rheostat works like a series resistance. It is given that the series resistance Rs is R itself. Then, that's the problem, right? Then what's further said? If the potential gradient of the wire is some value, what is the series resistance is the question. You want to calculate the value of this R, right? So you shall write what is the formula for the potential gradient. If you remember, the potential you in the secondary circuit you connect another EMF with a jockey, and then we'll put a jockey over here, and somewhere you will get some potential drop V. The potential drop for that V is equal to I into resistance of that piece. Resistance of that piece, Rx you call, right? Rx. So what is I? I is driven by this primary circuit. What is I is? Total EMF in the primary circuit, that is E, by the total resistance. What's the total resistance that it has? Resistance of this wire, that is R of that wire, R of AB let me call. Then series resistance that we have connected here plus internal resistance of that cell, that is total I. And then you want Rx, that is resistance of this piece. Let the total resistance of that wire R is RAB by the total length is L, that becomes linear resistance, resistance per length. Now the balancing length, assume you got it at length L. Into L, if you do, you will get the resistance of that piece. This is the equation for potential at the point where you get a balance. What is given for you is, be careful, is potential gradient. Potential gradient means potential per length. So get this L to this side now into the denominator. So what happens then? E by resistance of the wire, series resistance plus internal resistance, resistance of the wire by the total length. Now the potential gradient is given for you in the problem, that is 0.16 millivolt. I need to convert this, I will do it in the next step. Per centimeter is equal to EMF E is given for you in the problem. What is that? EMF is 2 volts. Resistance of the wire is also given for you in the problem, 20 ohms. Series resistance is R, we have to find out. Internal resistance is given as 0. Resistance of the wire is 20, length is 10. Now let us simplify this. 0.16 millivolts converted into volts in 10 power minus 3. Centimeter converted into meter, 10 power minus 2. This is 2 volts, of course, so the numerical value is 2. 20 plus R by 20 by 10 is 2. So what's the value further? 0.16, 10 power minus 3 by 10 power minus 2 is 10 power minus 1. 2 and 2 is 4 by 20 plus R. So if you simplify this further by rearranging the terms, 20 plus R, I am taking this to this side and this to this side. 4 by 0.16 into 10 power minus 1. So that is 20 plus R equal to 4 by 0.16 by 10. That is 40 by 0.16 is 20 plus R. Again 0.16 can be written like 16 by 100. So 40 into 100 divided by 16 equal to 20 plus R. So if I simplify this, 4 4s is 16 and 4 10s. So 20 plus R is 10 plus 100, 1000 by 4, that is 250. So R is 250 minus 20, that is 230 ohms. So what we have found is the series resistance that we have connected here with the help of the rheostat is equal to 230 ohms. So while we are solving this problem, we come across an important concept called potential gradient. Remember that potential gradient means potential per the length, that is has a unit of volt per meter in SI system. That's how we have to solve this problem. Thank you for watching.